Welcome to Scaling Up, the podcast where we celebrate Wastewater Thursday as the Scaling Up Nation. Happy Wastewater Thursday, everybody. My name is Trace Blackmore. I get to host this awesome podcast called Scaling Up H2O, and I hope you are having the best industrial water week possible. I know I am. I've enjoyed looking at all the pictures that you've hashtagged with IWW21 and Scaling Up H2O. Now, if I haven't seen your picture yet, it's not too late. On Monday, I asked you to send me a picture of you with your favorite piece of pre-treatment equipment. Mine is a water softener. In fact, its name is Rusty. We resurrected that, or we saved him from one of our customers. The old tank was just sitting in the back, and he's got a big rust stain down his side, hence the name Rusty. And Rusty now resides in our warehouse, and we use him to help us blend our products. So what are you waiting for? Show me your version of Rusty. While you're at it, if you haven't taken a picture of your favorite boiler, go ahead and do that too. Now, years ago, when I was working with my dad, I had a laundry that I serviced, and normally boilers are referred to as number 1 and number 2. Well, these boilers were not referred to as number 1 or number 2. One was Thelma and one was Louise. You might remember that was a movie. And they had special plaques proudly hanging above each one of them in their own font, mind you, that proudly said Thelma and Louise. And folks, I said this on a way early episode when we were talking about service reports. I used to call them number 1 and number 2. There was actually a sticker on them that said 1 and 2, and nobody in that plant knew what I was talking about. I had to start calling those boilers Thelma and Louise in order to get people to do what I asked them to do. When I used the right communication, I was getting the right results. I had to call them Thelma and Louise. By the way, that was a national linen plant that I used to service up in Newport News, Virginia. Any listeners up there? What is that plant now? Are you maybe servicing Thelma and Louise? If you are, I would love to know that. I don't know if the plant is still standing, but if there is a Scaling Up H2O listener that is servicing some of my favorite boilers, I would love to hear about it. Now, yesterday, I asked you to take a picture of you in front of your favorite cooling tower. And I have to say, for me, that was really hard to choose from. I mentioned yesterday, I just gravitate towards cooling, and I don't know if I have a favorite cooling tower. However, I will say that one of my favorite, hands down, behind the scenes tour was when I got invited up to Taneytown, Maryland, and I got to visit the Evapco plant. I saw how these cooling towers that we're charged with treating every single day, how they are made and all the technology that goes into them before they're made and how they're figuring out what the next version of all these products are. It's just amazing what Evapco has done, and Evapco has been a great friend to this show. So if you haven't taken a picture of any of those systems that I just mentioned, please take an opportunity to catch up today, and remember, as you post them, hashtag IWW21 and Scaling Up H2O so we can all enjoy those. Well, Nation, today is Wastewater Thursday. And I remember one of my first wastewater experiences that I had with my dad. And my dad took me to this place, and I think I can call it by name because I'm pretty sure they're not around anymore, but it was called Natalie's Knitting in Virginia. And I remember they made sweaters, and after they made the sweaters, it would go through a dyeing process, and the dye was the issue. The dye was coming out too high and making its way down to the local municipality, and it was upsetting what the municipality had to do to clarify their water, and they didn't like it. And they came to the plant and they asked them very nicely, in the way municipalities do, to fix that problem. Well, it didn't get fixed. And by the way, that wasn't my dad's account at the time. They then came and they asked a little bit firmer, and it still didn't get fixed. And because of my dad's connection, somehow he got involved, and my dad was asked to go up there and help. And my dad took me along for training, and what we were doing, I helped. We were trying to find the best flocculants, the best polymers that we could clear up all of this dye out of the water. Now, I don't remember what combination we ended up using, but I do remember that this was my first experience ever with jar testing. So we had 4 jar stirs going at the same time, and that's called a gang stir. And I could have sworn my dad called it a gangster. And I mentioned that on an earlier episode, and I get teased about that just like I did when I called it a gangster in front of all the people that were watching my dad do his magic trying to get the water to change to clear. So again, everybody has a good laugh on Trace Blackmore. That's fine. We're all having fun. I remember that it seemed to take a while, all these different combinations that he was trying, and some would kind of work, and then others wouldn't work at all. And it seemed to take a while, but then when he started figuring out what kind of worked, he was able to extrapolate, well, if that worked, I know enough about these other products that I can eliminate some that aren't going to work, and I can just hone in on the ones that have the right molecular weights and the right qualities that we're looking for to get the results. And once he did that, it started going pretty quick. And it was impressive how my dad kept track of everything. And when he started finding the right combination, he then started dialing it in. And that jar became quick at the snap of a finger. So my dad then took that and he multiplied it out by the whole system that he had to treat. And then we went out, and I remember we unloaded bags off of a pallet and had to carry them through the plant. We had other 5-gallon pails we had to carry through. And then we had to clean everything that they were using out, flush everything through, and hook all this new stuff up. My dad programmed what needed to go in. We actually had to wait several hours for a new batch to come in so we could just test what he worked out on a brand new, unadulterated batch by the old formula that was there. And then he fed it, and it worked just like it did in the gang stir. That was so impressive to watch. It was so gratifying to see all that work come together. And the coolest thing was, because we had to wait so long, it was now the shift where the plant manager was there, and he saw the whole thing. So he didn't see all the hard work my dad put in. Now, some of his supervisors did, and they were reporting to him what my dad did. But what he got to see was the end result. And he was so impressed. He shook my dad's hand, and he got a purchase order right then. Now, who am I kidding? My dad was not very good with paperwork, so he probably didn't get a purchase order. He probably just got a handshake, but he started doing their business. And I just remember thinking how cool that was. And that was my first encounter with wastewater. And I remember thinking, after all the things were ordered, and all the how wonderful this is and all the things that you've done, that they're buying something that they're immediately flushing down the drain. And I remember thinking, actually, I didn't think it. I told my dad that what a waste that was. And my dad told me that I was thinking about it all wrong. He said that they're paying us so they can stay open. Without our help, that municipality would have eventually shut them down for non compliance. He told me that what we did that night is we saved everyone's job that worked there. Nation, if you do not see how awesome being an industrial water treater is through this story, this was where I knew an industrial water treater, if they did their jobs right, they were superheroes. Hundreds of people were employed at this plant. And because my dad knew what to do, they had a job to come to tomorrow. That was just amazing to me. And I think I always enjoyed water treatment, but that was the day that it locked me in that this was a really special career. Now that we've gone down Trace Blackmore's memory lane, let's do that again with some of our episodes. Here's an excerpt from episode 53. This episode originally aired October 4th, 2018. And this is where friend of show Kevin Cope gave us some tips about jar testing. And yes, if you listen to this episode, Kevin also makes fun of me calling it the gangster. In fact, when he does AWT training, he brings that up to everybody that sits in the class. There you go. If we're all having fun, I'm having fun too. It's not a gangster, it is a gang stirrer. Anyway, here's Kevin. So now that we know what a jar stirrer or a gang stirrer, or in my case, a gangster is, how do we make sure that we're using it properly? How do we make sure we're mimicking the system? But then as you were going in, how do we know we even need to use it? Or when's the best time to use it?
One of the things I always do when we do our wastewater training class is one of the questions I always ask first in jar testing is, what are you trying to do? Are you trying to remove zinc? Are you trying to remove oil? Are you looking for better settling? Are you looking for an easier program? Or are you trying to reduce costs? Those are some of the key, and many others, but those are some of the key questions that you really do need to establish before you run your jar test. One of the things I always say is we can add inorganic polymers till we're blue in the face, and we're not going to precipitate zinc with an inorganic polymer. So you really need to ask the customer, what am I trying to remove? What are my problems? And those are really issues that are really key to setting up a correct jar test. And as James has asked, to mimic what's going on. So those are really keys. Well, once you have that established, you know what you're trying to do. One of the things I like to do is, walk the system or tour the system. See what it looks like. Do a line diagram. I'm great for drawing line diagrams and things along this line. Ask for swings in the application. Do they clean on the weekends, so therefore Mondays are always bad? Do they run 24 hours a day? What are the contaminants? What are the degree of contaminants? Does it vary greatly or does it vary little? Look for where the products are being fed, where their current programs are being fed. How are they being fed? Are they being diluted? Are they neat? Is it a batch or continuous operation? And the key here, Trace, to me is when I'm walking the system, I always, always, always look for points that I can take samples and look at the water. And we'll get into that later, but that's really a key point for me, is any system that I walk through, I always look for, if they're adding a coagulant, is there somewhere after the coagulant's added that I can get a sample? And that's really a key for me when I'm walking through a system. And then, you look at what are the products that they're being used and understand the function.
Our next episode takes us all the way back to October 8th, 2020, and that's episode 162.
So once primary clarification is done, we move into secondary. And secondary clarification is really where you're going to take out some of the dissolved materials, specifically the BOD, COD, things that can be biologically broken down, all right? In our industry, I don't know what the percentage would be, but I don't think we're going to see a lot of the secondary treatment. We may. A lot of the food plants, almost every food plant will have secondary treatment. And what happens there is you have bugs. And when I started in this industry, and the first time I heard somebody call them bugs, I just looked at them like, really? That's the word you use? And that is the word that is accepted when we talk in this industry. So what happens is you have these aeration ponds where bubbling air all the time. And there's bugs in there. And these bugs will eat the organics and break them down. Okay? And these bugs will break these organics down, cleaning the water. And then this water that has all these bugs in it will be taken and brought into a clarifier, just like we just talked about, where they'll settle out. The clean water will continue. We'll get into where the clean water goes in a minute. But the sludge, the bug sludge that settles to the bottom, that is one of two things can happen to that. They can either recycle that back to the beginning of the secondary treatment, or they can waste it to get rid of some of the bugs. Now, here's why, and this is another little way somebody explained this to me that stuck with me my entire career. If you think of the biological aerobic digester, is what it's called, an aerobic digester, there's air present as a community. And you think of that as being people, okay? And you have these bugs, basically people. And you have young bugs, you have medium-aged bugs, and you have old bugs. And if you think of our society, really the young people, the young babies and stuff really don't do a whole lot of work for the society. But now you get to the middle age, young adults to, little older adults, really who do the primary work within our society. Then you have the elderly, which really don't do a lot of work. So what happens is, in this bug community now, if you start getting too young, the bugs are too young, you don't get a lot of work. If the bugs start getting too old, you don't get a lot of work being removed of the organics. So what these customers will do is they'll take this sludge and they'll analyze it. And they'll say, well, we're getting too old. We're going to waste some of the sludge to move the sludge age more down into the medium range. And conversely, if we have too young of a sludge, we won't waste. We'll let those bugs become older and become more in that center group. And so that's always stuck with me on how to explain biological treatment. So what you're trying to do is have a healthy community of bugs which break down the organics and clean the water and taking the organics out. And you do that by aeration, where you have the air, just like our society, air. You have food being the waste that's coming in. And then you have the bugs, the communities that are breaking this material down. And again, that's called secondary treatment.
Also, from that same episode, we listened to a Detective H2O installment. Nation, I know you love these as much as I do. James McDonald, he is the brain, the voice, the editor, all the things behind Detective H2O. James, please know that the Scaling Up Nation loves Detective H2O. We want more of them, and I'm pretty sure the Scaling Up Nation wants Trace Blackmore to play a role. Just saying. Nation, here's another installment of Detective H2O.
Welcome to Detective H2O, the case of breaking free. The rain ran serpentine paths down the windows of the rusty blue Ford as Herbert Henry Oxidane, P.I., CWT, sat waiting for Johnny Keelan to open a side powerhouse door at Pork Belly's Processing. When the lanky man's shaggy head popped out, the water detective made a run for it, dodging raindrops the best he could. Get in here, H2O, before you melt. I'm running between the drops. Let's see this reverse osmosis system of yours. Right this way, said Johnny as he snaked his way through the building. Like I said on the horn, this RO system goes south real fast. We'll clean it good. And a week later, maybe two, it's moping along, begging to be taken to the cleaners again. How do you determine when it needs to be cleaned? Well, we're using the normalization program provided by the membrane manufacturer. When the normalization permeate flows drop by 10 to 15% and the pressure drops increase by 15%, we clean. We're barely keeping up with the permeate demand. Can you tell me about the water you're processing through the RO system? Oh yeah, we're the largest pork belly processing plant this side of the Mississippi, you see. That requires a lot of water. We get our water directly from the Grace Noel River. After filtration, clarification, and disinfection, some of the water comes to this RO system to make high-purity water for us. Our silt density index is run daily. It is always spot on, showing good quality water for RO membranes. Our free chlorine test before the RO is also always spot on, before the dechlorination step, you see. Yet despite my crew babying this system, the membranes have to be cleaned far more frequently than we ever imagined. That can't be good for them.
Have you sent any of the membranes out for an autopsy to determine what is fouling them?
Yes, 3 times. It is always biological fouling.
Biological fouling. Interesting. Let's take a look. I'd like to walk down the length of the system, see the chemical feed points, review your data, take a look at the autopsy reports, and run a few tests myself. Let's start with the walkthrough.
For the next several hours, the water detective got the scoop on the Pork Belly's processing water treatment system. Everything appeared to be ship-shape. This was a well-run plant, and as far as he could tell, well-designed. The crew's care and dedication were obvious.
Figured out the culprit yet, Detective?
Not quite yet, but I have a hunch. Let's go collect some water right before the chlorine disinfectant is added. We'll need a clean bucket.
After collecting the water sample, Detective H2O lined up several beakers with 100 mLs of the water sample in each, prepared a diluted bleach solution, and carefully injected different amounts of the solution into each water sample. After thoroughly stirring, he started the timer. In the meantime, he also tested for ammonia. Earlier, the water detective had calculated the residence time of the chlorine disinfectant in the system from the point of injection to the point of dechlorination just before the RO system. It was 25 minutes. After this time elapsed, he tested each 100 ml water sample for free chlorine. Then he fired up his computer, barely more than an abacus, and graphed out the data. Lastly, he smiled, or at least he defined it as a smile. Johnny, noticing the change in the water detective's face, said,
I don't know whether to be scared or encouraged by that. Smile you've got going on there. Are you on to the culprit?
Definitely encouraged. I may have cracked this case wide open. Take a look at this. I added different levels of diluted bleach to each of the water samples you saw me pour out. The chlorine concentration added increased from left to right as I had them setting on the lab counter. I gave them time for the free chlorine to react with whatever was in the water, the same time it would have in the system out there. After this time, I measured the remaining free chlorine. Finally, I graphed it out here. See this curve?
Yes, there's a bump in the middle. Is that normal?
Well, yes and no, but it's what I suspected I would see in your case. When chlorine is introduced to a system, it reacts with several things. Our desire is for it to react with the microbes in the water first so the water is properly disinfected. That way your membranes won't foul. Unfortunately, there are other components in the water that can react with the chlorine even faster. The typical culprit is ammonia. Ammonia can get into surface waters from farm runoff and so forth. When ammonia reacts with chlorine, it forms chloramines such as monochloramine, a form of combined chlorine. Now, chloramines are a disinfectant, but some research shows that monochloramine may be 25 times less effective than free chlorine at killing microbes. To get the killing power of free chlorine, you must first react with all the ammonia. After the ammonia is gone and the chloramine reactions are at completion, the remaining chlorine disinfectant you add will form free chlorine. This is called breakpoint chlorination, and that's where the upward sloping line starts after the hump on the graph.
Okay, I get what you're saying there, Detective H2O, but I still don't get what it has to do with us. We test our water for free chlorine every shift, not monochloramine, but free chlorine. It is within the control range every time. That should be good enough, shouldn't it? What gives?
Yes, you make an excellent point, which brings me to the second part of my story. What you see isn't always what you get. Monochloramine can be a positive interference to the DPD-free chlorine test you use. That means even though the sample turns pink and you think you have a true free chlorine residual in your water, it is actually monochloramine interfering with your test. You don't have the killing power you think you have in your water, which would certainly explain the biological fouling on your RO membranes.
And you're sure this is happening to us?
I tested the water prior to disinfection for ammonia and found it. Look at this level.
To reach breakpoint chlorination, you need to feed a weight ratio of 8-to-1 or higher of chlorine to ammonia. Based upon your records and data, you're only feeding enough chlorine to get halfway up the hump. There's no true free chlorine at all to do the disinfection you want.
Wow! What do we do?
You have a few options. First, you can feed more chlorine to the system to reach breakpoint chlorination and beyond to your true free chlorine control range. Second, you could supplement the chlorine biocide with another biocide, which is RO membrane compatible. Third, you could look at replacing the chlorine biocide with another one that may be more effective considering your current water conditions. There are other options we may be able to consider as well. There are pluses and minuses that come with each option. We can do a thorough feasibility analysis on each of these options, but let's prove my theory first by feeding more chlorine.
That sounds like a good plan, Detective H2O. Thanks for your time.
Detective H2O's suspicions were proven to be true over the coming year as the RO membrane cleaning intervals increased from weekly to quarterly. After initially increasing the chlorine feed, a disinfection feasibility study was conducted, systems were piloted, and changes were made that increased the cleanings to every 6 months. Detective H2O had truly saved the day once again. In the underbelly and penthouses of the metropolis of Waterville, where the boilers percolate and cooling towers fog, there is one man who works tirelessly to end corrosion, stop scale, fight low-life microbes, and conserve water. That man is Detective H2O, best water treater this side of the Ohio, solving water problems, drop by drop.
In the beginning of this episode, I asked you to catch up with all of your picture posting, but I didn't ask you to post today's picture. This is what I want you to go stand in front of and take a picture of. Whatever your favorite piece of wastewater equipment is, proudly stand in front of that, snap a picture of that, upload it to your favorite social media site, and hashtag it with IWW21 and hashtag scaling up H2O. Nation, today's celebration wouldn't be complete without a new Mini James challenge. And again, the challenge is mini. We haven't shrunk James McDonald. We've just made the challenge a little bit smaller. So here is the new mini challenge.
Hello, Scaling Up Nation, and happy Industrial Water Week. Today's Wastewater Thursday, James's mini challenge is post a picture of pin floc separating. So much of what we do in industrial water treatment is inside pipes and vessels. Wastewater treatment is where we often get to see the magic right before our eyes. Seeing suspended solids separate out as pin floc can be where the mystery starts revealing itself. Most of all, be sure to share your pictures on LinkedIn and other social media by tagging it with hashtag IWW21 and hashtag ScalingUpH2O. This is James McDonald, and I look forward to seeing what you share.
As you can tell, I love celebrating Industrial Water Week with you. I hope you love every bit of Industrial Water Week as I do. I hope you're sharing it with other industrial water treaters. A lot of people don't know that we have an entire holiday week dedicated just for us. And Nation, with the story that I shared with you earlier, we should probably have a whole month because I know you have stories just like that. And I also know that you're going to tune in tomorrow to celebrate our last day of Industrial Water Week, Careers Friday. Nation, I've really enjoyed sharing with you some of the stories in my history that taught me how to be a better industrial water treater. Well, just imagine every single week joining a group where you can talk about technical issues, personal issues, any type of issue that you feel you need help with, and you can get the expertise of people that have already dealt with that issue. You can get the advice of people that care about you, and they want you to take the next best step. And when you complete it, they're going to celebrate that right along with you. If this sounds like something you want to be involved with, go to scalinguph2o.com/mastermind to find out more.